So I just want to explain the relation between, so the trivial relation between the Theta-Pilot object and the Q-Pilot object. So this is the simple one. So recall that PQ, so this is the Q-Pilot divisor. So this is equal to the sum V and V F naught. F naught's the field of moduli, so these are bad places. So these are places that are not potentially good. You take the order of the valuation here, and we do it like this. And so this is a divisor in F naught, so an Arikhelov divisor. P theta is a tuple of P theta j's, from j is equal to 1 to L minus 1 divided by 2. This thing is a divisor. It's a tuple of divisors. It's like an L, what we can call a LGP tuple of divisors, and all it means is that there are Arikhelov divisors, but you average them. And here, when you take degrees, you're just going to take the average degrees. That's what I mean by you average them. So this is the same thing, bad, and here you take it to the j. Oh, this is double underlined. The double underline means you take the 2l root. Go like this, and so now this is in a fancy one. So this is like this Fraktur LGP thing that appears in IUT3. This is an artifact of the construction of the reconstruction of evaluation points in IUT2. Okay, so there's these things, and then so this is the Theta-Pilot divisor. So this guy here is the Theta-Pilot. And the relation that we're looking for is that you take this Arikhelov degree. It can be normalized or non-normalized. The underline means normalized. Here, we saw that this is related to the minimal discriminant of the field K or F. So again, in this discussion, we're fixing initial theta data. That's not so important. And then, so this thing is going to be equal to L times L plus 1, or L plus 2 over 12, I believe. And then you take the degree, LGP degree F naught of P theta. Okay, so this is the relation that we're after here. And this comes up in computations. This thing will appear in the computation in IUT4. I need to make a small correction right here. This formula should read L times L plus 1 over 12. Okay, and there's okay. So I should say that there in the paper that there's kind of a volume theoretic, a measure theoretic incarnation of these things, and a divisor version of these things, and so you kind of have to pay attention to when he's talking about which. The proof of this is quite elementary. I mean, it's not really a proof at all. It's just like a computation, right? And all it is that you just have to know what the definition of taking a degree of these LGP things, and this is an average. F. So this thing here. So this is the sum, so you take the average. So there's L minus 1 over 2 of them. So this is like this L divide on times thing, this symbol. That's that number. J is equal to 1 here. And then we do ord V Q double underline V J squared V. Sorry. Let's do it like this. Degree F naught P theta J. And then this thing is 2 over L minus 1, sum of J1 L minus 1 over 2. And now this thing was this Gaussian business here. So this is just j squared, like the degree of the q-pilot. Okay, and so then this just becomes the sum of those two things. And if you compute out what this is, so this is exactly what I stated was, this is L times L plus 2 over 12, and then just multiplied times the other thing. That's all there is to it. I should remark that kind of the crux of what Schulze and Stix are saying in their manuscript is that this is the only relation that there is, and that there's no Abelian procedure to somehow encode both of these things into some region where you can get a non-trivial relationship. Like, it's saying that the Abelian geometry and this kind of like switch he does at the end doesn't work. Okay.